Tim, great to see you. How are you?
Hello, Dallas. Great to see you too. I'm very well. How are you doing?
I'm doing all right, actually. I'm doing. The sun is shining. I feel quite positive and buoyant today.
Spring is in the air.
It is in the air. It is in the air. Hey, listen, I've got to ask you. Did you watch the great excitement last month of the
Oh,
landing? Were you watching it live?
absolutely. Absolutely. I had my heart in my mouth like so many others. I mean, they talk about that 7 minutes of terror, but it's just such a monumental achievement. And every time you see that, I know we saw it with Curiosity rover, but again, it's like something out of science fiction, isn't it? It's like watching Thunderbirds, thinking of retro rockets and sky cranes lowering a rover onto the red planet. It's the stuff of science fiction. It's brilliant.
It really is. Although there is this kind of thing because they've sort of done it once. I mean, it's not. We couldn't ever say it's routine, but I heard some people online going, "Oh yeah, we've seen it before," and I'm like, "This is like the hardest thing that humans have ever done," and people
Yeah.
are still already complaining that they're slightly bored of it.
I know the fact that it's traveled over 400 million kilometers just to get there over 6 months, and this thing is autonomously doing all of this by itself. It's
Yeah,
unbelievable, and it's a heavy rover. It's a
it's
it's
a
a
one
ton. I
ton.
mean,
That's a ton of
that
metal.
that's a ton of metal that is
Yeah.
being lowered by a sky crane using rockets in a very, very thin Martian atmosphere. I mean, the engineering challenges are overwhelming. So it's a really audacious challenge, really is.
It really was, and actually, those sort of first images that we got, or a couple of days afterwards, where we actually saw the videos of the kind of the back shell leaving and the parachute opening. It was, you in a way, it was funny because it almost looked kind of normal. It could be like on Earth. It could be watching a parachute open on Earth, and you'd think, well, that's relatively normal. But you have to. Your mind does a somersault. We think, no, no, no. That's on Mars. That is on Mars. That is a parachute opening at supersonic speeds on another
Yeah.
planet, and it is the stuff of
It's crazy.
science fiction.
And the other thing I thought as well, when you watch it on your monitor, or your TV or whatever, and then you go out at night and actually look up at the red planet and just think, what I've just seen on my laptop is actually there, right in front of me. I'm looking at it now, and that's incredible to see as well.
I mean, it's quite interesting as well because this month obviously we saw the United Arab Emirates orbiter there as well, and a Chinese rover. So it's kind of everything sort of converging at once on Mars, and of course,
Yeah.
presumably that's because of where Mars happens to be in the sky at this time. So all that planning would have been done months and months before. This is where Mars is at its
Yeah.
closest.
Absolutely. It's all to do with the planetary orbits. And of course, Earth, if you like, is closer to the sun. It's on the inside. And so it will orbit faster. And the planets that are further away from the sun will orbit slower. So for every 1 year of Earth, it takes Mars 2 Earth years to go once around the sun. So because the planets only line up every 2 years, that's the opportune moment to go and send your rovers off to Mars, which is why we had three kind of missions all arriving at Mars at the same time.
Yeah. Okay. Well, let's just talk about the rover itself, just in terms of the sort of science package that is on that particular spacecraft. And there are obviously similarities with Curiosity, but what is it about this particular mission that's of interest to you? What are you kind of most excited about, do you think?
Well, I'm really excited on a couple of things. Firstly is the location, because the location has been specifically chosen for one of the parts of Mars that we think may harbor evidence of past life. So, about 3 billion years ago, Earth and Mars were actually remarkably similar in terms that Mars had a liquid ocean, probably covered about a third of the planet, and it had a much warmer, much denser atmosphere. And of course, Earth's early atmosphere wasn't full of oxygen at all. There was no oxygen on Earth's initial atmosphere. So Earth and Mars kind of came from similar beginnings. And if life could evolve on Earth, then perhaps life has also evolved on Mars. And that's what Perseverance is really out to try and answer. So that's really exciting. It's picked a great location, a location where we think there was once water, and also, shallow water that would have had that nice warming effect that we think might have created the building blocks of life. And also, of course, it's going to be drilling down into the surface of Mars. It's going to be, finding samples that we can analyze. And also in the future, it's leaving samples that potentially a European rover can come along later, pick up and return to Earth. So there's loads to get excited about.
It really, actually, the Jezero crater, it is amazing when you look at it. It could be a dry river delta on Earth. It's, you know, in the high deserts of the United States, for example. I mean, you look at the processes at work there, the geological processes, and they match so closely. I'm really excited because, you know, whatever the answer we're going to get from this, it's going to be interesting. But I do feel we're starting to kind of get closer and closer to getting some answers about, you know, ancient life on Mars on some level. I mean, I remember, well, back at, you know, in the 1970s when the Viking rover did, which had a kind of a biological package on, but they didn't really get any conclusive answers at all. And this hopefully is going to give us an answer. We're not talking about life living there now, but certainly, you know, the profound implications if we did find that there was evidence of prehistoric life, I think it's going to be immense.
It will be immense. I mean, it would completely change our perspective. Here we are, you know, thinking that we're the only planet in the universe right now that harbors any life at all because we've got no evidence to suggest it is anywhere else. And then suddenly, if we find out that our neighboring rocky planet also, you know, evolved life independently, then that changes the ballpark. Life, you know, I think life's prevalent throughout the universe anyway, but I think this would really prove it.
Well, this is it. We've got one data point, which is Earth. But as soon as you've got two data points, then you can say with a degree of certainty that life is common throughout the universe, I would say. It's amazing. And actually, as you said, the idea of the return samples, the fact that we can bring samples back, this sort of future mission that ESA is involved with as well, with the Fetch rover. I mean, talk about the engineering challenges of the 7 minutes of terror. The next bit, where they've got a lander and a rover and a rocket on Mars and an orbiter and a thing that fires it back to Earth. That's like next level.
It is absolutely. I mean, the level of complexity we're getting to now is it's brilliant, frankly, because it's helping to ultimately to pave the way for human missions to Mars. And you know, we're starting to do more and more audacious things. And if we can overcome some of these engineering challenges with a 1-ton rover, then we can upscale that and start to look at how we can do that with, you know, a 5-ton human rated vehicle. Yeah.
Okay. Well, let's talk about that. So, since I was a kid, we've been talking about going to Mars, and then we all get very excited, and NASA's all the, you know, gateway paving the way to Mars, and then we sort of slightly forget about Mars, and then we move on to other things. When are we going to be going to Mars? I mean, will I still be alive when we go to Mars, or are we? I know we're doing Moon first and then Mars, but
it's a difficult question to answer. I mean, if I was going to answer it directly, my sort of finger in the sand is going to say somewhere between 2035, 2040. I do think it will be by the end of the next decade. Then there's some interesting things, you know, Moon first, Mars first. There was a lot of debate about that. Many people think we should have just gone straight for Mars. The problem is that, as we kind of mentioned about this planetary alignment, if that's not hard enough, you know, let's not forget it took over 6 months for these missions to get to Mars. And when we're going to send humans there, we don't want simply do it, land on the surface and come straight back again. We want to have a meaningful scientific mission. It's probably going to be a 3-year round trip. That's an incredible undertaking for a human mission out in space. There's problems with radiation. There's problems with obviously food and sustainability, and propulsion systems need to be upgraded as well. So there's lots of things we need to overcome. And it's you know, the moon is 400,000 kilometers away. It's 3.5 days. Mars is 400.
It's always the same distance away as well. Conveniently, the moon's always just there. I mean, I think people forget that.
At some point during that human mission, Mars and Earth will be on opposite sides of the sun.
In terms of difficulty, in terms of like a Mars mission, is the difficulty we haven't just got the science and the engineering there yet in terms of sustaining a mission to Mars, or how much of it is political? We just don't have the political will. We don't have the finances in place yet.
I think it's a mixture of everything. It's a long process, and you're right about the political will, because it takes an awful lot of investment in terms of time and money in order to do human space exploration. You know, when NASA did the Apollo missions, it was eating up 5% of their GDP. That's unsustainable for any nation in peacetime to kind of dedicate those resources. So hence the International Space Station has been so successful, because it's been this partnership. It's reduced the cost for every nation involved. But then the flip side of that, if you're going to build a $100 billion space station, you need to maximize the use. And we have for over 20 years, it's been occupied, and we're getting some great science back from the ISS. But whilst we're using a space station, it's very hard to then have an exploration program to the moon on Mars at the same time as running an international space station. So we kind of get ourselves into this cycle where we're dedicated to one thing. And what we're trying to do now is hand over low Earth orbit and the ISS to commercial companies to free up those resources to allow us to go to the moon and Mars. And the moon is really a de-risking exercise in terms of trying out some of the technologies we need for Mars. But the moon is also a fascinating location in its own right. I mean, the Apollo missions literally scratched the surface, and we've still got so much to learn from the moon. So I think as a test pilot, I think it's quite a logical step. It's an incremental step on the way to Mars.
I agree, and I'm also absolutely fascinated by our moon adventures that are to come. But as a test pilot, actually, my next question is this: lots of interesting science on Perseverance rover, but the one that's probably caught everyone's attention is the helicopter. Well, I say helicopter; it's a drone, but as a helicopter test pilot, presumably you must be delighted about this.
Yeah, it was so exciting to see it, and I can't wait for the first test flights to occur. And at the moment, this is a technology demonstrator, but wow, it would be the first powered flight on another planet to our knowledge. So this is really, really exciting, and it's incredibly challenging too.
Well, actually, just tell us about the challenges of flying a helicopter on Mars. So why is flying a helicopter on Mars more difficult than flying a helicopter on Earth?
Well, you've got one thing in your favor, and that's gravity. And Mars is about a third of Earth's gravity, but that's about the only thing going for you, because the atmosphere is only 1% of Earth's atmosphere. And if you want to generate lift on a blade, whether it's a rotor blade or a wing of an aircraft, you need a few things in your favor. A greater air density is going to help you. A greater surface area is going to help you. A faster velocity of the air is going to help you. And also things like angle of attack. How is your wing angled to the direction of the air? And so all of these things factor into the lift equation. And Mars is challenging because it's got such a thin atmosphere that you're going to have to spin the blades really, really fast, 5 times faster than a normal helicopter would on Earth. They're going to need a much greater surface area, a higher angle of attack, and they're going to have to be very rigid and stiff, because in a thin air, blades start flapping up and down. And in Earth's atmosphere, that's dampened by our thicker atmosphere. So they've, having to overcome lots and lots of challenges to be able to fly this helicopter in a Martian atmosphere.
What about controlling it? Is someone at sort of JPL kind of, how does that work? Not quite.
Can you imagine?
I can't fly a drone.
To fly your radio-controlled helicopter with a 7-minute delay. Well, it's going to end in failure.
That's what I'm trying to get my head around. But you've done this before, didn't you? You've flown a drone when you were for the Nemo, which is the underwater training.
That's right. Yeah. So I did a 12-day mission to Aquarius, the underwater habitat, and we were, down at about 25 meters. And so I wanted to do a little experiment with my own radio-controlled helicopter to see what that change in atmosphere would be like. And of course, I was going the other way. I wasn't going into a thinner atmosphere. I was going into a much thicker atmosphere underneath the water. And so on the quay side, I lifted up a small underslung load full of sweets, and it lifted about 14 sweets in this underslung load, and that was the maximum it could lift. And then with exactly the same helicopter and the same battery charge and everything, it could lift way over twice as much inside the habitat, because of course it's got a much thicker, much denser air so you're getting greater lift off of those rotor blades. That was going the opposite way. I was going in a beneficial direction, whereas on Mars they're not going in a beneficial direction.
Were you controlling it, or was it autonomous? Because the one on Mars,
I was controlling that. And what really surprised me, because of course it didn't surprise me at all that it would be able to carry more weight. I'd worked that out and I knew exactly what those calculations were. What really surprised me was how easy it was to fly it in the habitat. I was terrified about bashing into something in this small space. It was so easy, because of course, the control surfaces, you only needed to move the controls a tiny amount, and in that lovely thick air, the helicopter would respond easily and automatically. So what also, is going to be surprising with Ingenuity, if it was so much easier for me to fly it in a denser atmosphere, how much harder is it going to be on Mars? I mean, this thing is going to be very skittish. It's going to be all over the place, and it's going to have massive, control movements in order to counter any instabilities. So it's going to be very, very tricky for it to fly. And of course, it's not going to be someone with the controls. It's going to have to do it automatically, autonomously.
Well, didn't you do that on the space station one? Didn't you have to drive a rover in Stevenage, which is like
I did, yeah. I was
Stevenage, Mars. It's the same kind of thing. Well, the Mars Yard, they've got their wonderful Mars Yard in Stevenage, I know.
That's right. Yeah. That was a lot of fun driving. In fact, that was the prototype rover, which will be hopefully launching in 2022, the ExoMars rover, which is now the Rosalind Franklin. So that's what I was driving around in the Stevenage Mars Yard.
Well, actually, just while I've got you, I've got to ask, as an astronaut, I mean, let's look a little bit beyond the moon. Would you relish something like a 3-year mission to Mars? I mean, because as you say, because of the way that the planets are aligned, if you're going to Mars, you ain't coming back anytime soon. So you're going to be there living off the land for a long time. Is that something that is appealing to astronauts, or something that is just a little bit too daunting, do you think? I mean, given our longest stay is a year on the ISS, 3 years.
Yeah. No, I think it's very appealing. I think that, the more we get lured into Mars, we see views coming back from Perseverance, Curiosity, and we look at that terrain and think, hang on a second, we can achieve this. We can go and set up a habitation module there. We can live and work on another planet. It's incredibly appealing. I think the one difficult thing will be, making sure that timescale fits in with the person or the astronauts, the crew who needs to go and fly. At the moment, with a 9 and 12-year-old at home, as a father, it's probably not the time to be embarking on a 3-year mission to Mars.
Although there are times when I think actually looking pretty tempting.
Right now, it's looking very appealing. Yeah.
Actually, on that, I've got to ask you, because the other big exciting news recently is ESA's announcement that they're taking on the next group of astronauts. Now, you were in the 2009 group, so it's been a while since they've taken on astronauts. Are you excited about this? I mean, is the next group, will they be the astronauts who are going to hopefully maybe set foot on the moon, do you think?
Absolutely. Yeah, I'm really excited about it. And yes, they will. I mean, Europe is very much part of this Artemis exploration program that's going to see us return to the moon. ESA builds the service module for the Orion spacecraft that's going to carry the astronauts back to the surface of the moon. And so, it's very exciting that ESA is now selecting a new cadre of astronauts. And we hope to have these selection processes more frequently now, maybe selecting fewer astronauts, but having them more frequently. And it just offers, the next generations the opportunity to push the boundaries and become space explorers. So really excited. It's
been really exciting. And obviously it's sort of generated loads and loads of headlines, and everyone's got very, very excited about it. I might even put in my own application. You never know. Because I think a sort of 50-year-old, I think with my 2-2 degree in English, I think that's exactly what...
Absolutely, Dallas, go for it.
ESA's required. I was actually going to apply just so I could get the rejection letter and have it as my... frame it in the loo. But I will what apart from the degrees and all the sort of basic things that you would need in order to get through the kind of first stage, is there one kind of character trait that you think, I mean, obviously the job description of the astronaut has changed massively over the years as well, but what do you think is the one thing that you need to do a job like that?
It's really hard to sort of bring it down to just one thing. I mean, from a professional point of view, the one thing I think is judgment over and above everything else. You've got to make judgment calls that the space agency is able to trust you with. So it comes down to having good judgment. But good judgment itself might get the job done, but good judgment isn't going to make you the person that people want to spend 6 months in a spacecraft with, or longer, or 3 years to Mars. You've got to have the ability to get on well with people, and you've got to be very calm under pressure. Somebody who doesn't get too excitable. So I think it's very hard to nail it with just one characteristic.
I think that is a really, really good advice. Actually, the longer we spend there, actually just getting on with people and just being nice is quite important. But we should point out as well, I want to say as well, you know, you are a STEM ambassador. I think you're the first honorary STEM ambassador. So I want to talk a little bit about other careers in STEM, of course, because I mean, so much of what you did with Principia was about, you know, inspiring people in other jobs, not just astronauts. How important do you think it is for people to sort of become STEM ambassadors, whether voluntary or as professions, and actually go and talk about STEM to young people?
Oh, I think it's really important because I'm so encouraged when I go to schools, when I visit universities and I speak to other people, I'm so encouraged by how much enthusiasm there is out there right now for STEM subjects and also for just technology and innovation and engineering as a whole. And I think our younger generations have really grasped this and they know that technology is going to be at the core of whatever it is that they're going to do. You know, even if they're not going to go off and be scientists and engineers, if they're going to go into art, to drama, to literature, you're not going to escape technology. So people are really embracing it. Our younger generations are embracing it. And to go into schools and to actually kind of feel this and see this is really wonderful to kind of get that motivation, get that excitement that's bouncing back off students. And I think it's incredibly important. You know, when you look around at what's happening today in terms of things like artificial intelligence, in terms of sustainable technologies, you know, challenges that we need to solve, problems that we need to overcome, a lot of it's going to come down to having brilliant engineers and scientists who are able to help us with these challenges.
Yeah, I totally agree. And I think space is a wonderful portal for all of this as well, because space, it naturally engages our enthusiasm, our spirit of adventure, our spirit of exploration. But there are so many places you can go with it. And, you know, as you say, even beyond STEM, you know, it is part of our culture. It taps into our history. It taps into what it is to be human. So I think it is fascinating. I should say as well, the STEM Learning website, that's my plug. If you want to find out more about STEM opportunities, the STEM Learning website has loads of information you can get involved. And I want to say a big thank you to all the STEM learning volunteers who do so much in schools and outside schools who are just there. Hey, listen, we've run out of time. I think I could chat on forever, but I'll have to stop. Unfortunately, I've got my application to get in before the deadline.
Brilliant talking to you as ever, Dallas. Thank you very much.
I've missed the boat. Tim, lovely to talk to you, and I'll see you soon.
Likewise. Thanks, Dallas. Bye-bye.